You have probably heard whispers about the dark web. The term sounds intimidating. Dark web, like something out of a spy movie. But today, we are going to demystify this completely. We'll understand what it is, how it works, why it exists, and most importantly, whether you should ever go there. By the end of this video, you will understand the architecture behind internet anonymity, the technology that powers it, and the real-world implications of truly decentralized network. Let's start with a fundamental question. What exactly is the internet you can't see? Imagine the internet is an iceberg, the part you see above water. That's about 5% of the total internet. We call it the surface web. This is everything you can find on Google, Bing, or any search engine. Your social media feeds, news sites, Wikipedia, Netflix. Basically, if a search engine can index it, it's part of the surface web. Now, what about the other 95%? That's underwater, and it splits into two main categories. First, the deep web. This makes up the vast majority of the hidden 95%. But here's the thing. The deep web isn't scary or illegal. It's just not indexed by search engines. Think about it. Your Gmail inbox isn't on Google search results, right? That's deep web. Your online banking portal, deep web. Your company's internal database, deep web. Academic journals behind paywalls, that's deep web too. In fact, my ByteMonk system design course is also deep web. It's protected by passwords, paywalls, or it's just dynamically generated content that search engines can't crawl. Nothing sinister here, just private stuff. Then there's the dark web. This is the deepest of the iceberg. It's a small fraction of the internet, but it's deliberately hidden and requires special software to access. The dark web is where anonymity is the priority. And like any tool that provides anonymity, it can be used for both good and bad purposes. On one hand, there are journalists in authoritarian countries, whistleblowers exposing corruption, political activists organizing protest. On the other hand, we have illegal marketplaces, stolen data exchanges, malware distribution, and criminal forums. So it's not inherently evil. It's a tool. And tools can be used for different purposes. Okay, so why would anyone build this? For that, let's rewind to the 1990s. The US Naval Research Laboratory had a problem. They needed a way for intelligence officers to communicate without revealing their locations or identities. Think about it. If a spy in a foreign country connects to a US government server, that's a massive red flag. The connection itself reveals who they are. So they created the Onion Router, or Tor for short. The idea was brilliant. Create a network where your traffic bounces through multiple servers before reaching its destination. Each server only knows the previous hop and the next hop. Nobody knows the full path. It's called onion routing because like an onion, it has layers. Each layer of encryption is peeled off at each hop, revealing only the next destination. But here is where it gets interesting. If only government agents use this network, it wouldn't provide anonymity at all. You'd know that anyone using Tor is probably a spy. So they made it open source. They released it to the public in the early 2000s. And now, millions of people use it for legitimate privacy reasons, which provides cover for the people who actually need anonymity. It's like hiding in a crowd. The bigger the crowd, the better the hiding spot. And that's how the dark web was born. Not as a criminal enterprise, but as a privacy tool that happened to attract all sorts of users. Alright, let's get technical. How does this onion routing actually work? So imagine you want to visit a website anonymously. You install the Tor browser. This is a modified version of Firefox that routes all your traffic through the Tor network. Your computer then connects to the Tor network directory. This directory maintains a list of thousands of volunteer-run Tor nodes around the world. These are called relays. Your browser then selects a random path through 3 nodes: an entry node, also called a guard node, a middle node or relay, and an exit node. And your request gets encrypted in layers. Here's the clever part. Your browser encrypts your data 3 times. The data then travels through the network. Your encrypted packet reaches the entry node. It decrypts the outer layer and sees, send this to the middle node. It has no idea what's inside or where it's ultimately going. The middle node receives it, decrypts its layer and sees, send this to the exit node. Still no idea about the final destination or the content. The exit node receives it, decrypts the final layer, and makes the actual request to the destination website. Think of it like sending a package through multiple couriers. Courier 1 knows you sent something but doesn't know to whom. Courier 2 doesn't know where it came from or where it's ultimately going. Courier 3 knows the final destination but doesn't know who sent it. No single courier knows the full story. And finally, the response travels back through the same path. The website sends data back to the exit node, which encrypts and forwards it to the middle node, which encrypts and forwards to the entry node, which finally delivers to you. Now, this is brilliant for anonymity, but it comes with trade-offs. So if you were to actually access the dark web, what would you find? First, you need to understand onion addresses. These are special domain names that only work through Tor. They look like random gibberish. For example, this one. That's actually DuckDuckGo's onion address. Because these addresses aren't indexed by regular search engines, you need special directories to find them. Think of them like the yellow pages of the dark web. So what's actually there? The dark web has three main categories. First, legitimate users. Facebook's onion site. Yes, Facebook has an onion address so people in countries that block Facebook can still access it. ProPublica and SecureDrop help journalists protect whistleblowers. Privacy-focused services like ProtonMail offer secure communication. Second, the gray area. Cryptocurrency forums, censorship-resistant libraries, things that aren't illegal but operate outside traditional systems. And then, the illegal stuff. Dark web marketplaces that work like Amazon for contraband. When the FBI shut down Silk Road in 2013, others quickly replaced it. Stolen credit cards, login credentials, and personal data get traded like commodities. And you can hire hackers to break into accounts or take down websites. Now, I need to be really clear here. I am not recommending you go there. Even if you're just curious, you are putting yourself at risk. The dark web is full of malicious actors. Many sites automatically attempt to install malware on your computer, keyloggers, ransomware, spyware, you name it. Most illegal marketplaces are scams. People pay for illegal goods that never arrive. And what are you going to do? Call the police? In some countries, just accessing the dark web can be illegal. Even in countries where it's legal, accessing certain content is crime. So if the risks are this high, why do security researchers and companies bother monitoring the dark web? This is actually really important. Companies like IBM's X-Force and many cybersecurity firms have teams dedicated to monitoring dark web activity. And here is why. Threat intelligence. When hackers discover a new vulnerability or develop a new exploit, they often share or sell it on the dark web forums. Security researchers monitor these to stay ahead of threats. And when companies get hacked, stolen data often ends up for sale on dark web marketplaces. By monitoring these, companies can discover breaches they didn't even know happened. Stolen usernames and passwords get sold in bulk. Companies monitor for their customers' credentials so they can force password resets. And then there is trend analysis. What are hackers talking about? What techniques are they developing? This intelligence helps companies defend themselves. The key difference? These researchers use secure, isolated environments. They are not casually browsing on their laptops. Which brings me to our today's sponsor, Sevalla. I have actually deployed full-stack applications using their platform, and I want to show you how straightforward deployment can be. First, you need to create an account on the Sevalla website. Once logged in, you arrive at the Sevalla dashboard. We are going to do two things here. Create a PostgreSQL database for our app on Sevalla and deploy our Next.js application to Sevalla's application hosting. In the Sevalla dashboard, find the option to add a new database. Choose PostgreSQL. After a few seconds, Sevalla will provision a new Postgre database for us. It's fully managed, meaning Sevalla handles the setup, scaling, and maintenance. Copy the database connection URL and we'll need to supply this to our app. Now let's add our application. So I have connected my GitHub account and selected the repository containing our Next.js project. We also choose the region for our app, ideally the same region as the database for best performance. Now before deploying, we need to tell our app how to connect to the database. Now our app running on Sevalla will have access to process.env.database URL and can connect to the right database. We hit the deploy button, Sevalla will spin up a container to build our app. And here it is. Our app is on the internet. It looks the same as it did locally. The dark web represents a fundamental tension in the society. Privacy versus security. If you weaken anonymity to stop criminals, you endanger journalists and activists. And if you strengthen anonymity to protect the vulnerable, you also protect criminals. This is why the dark web continues to exist despite government attempts to shut it down. It's a tool, and tools are neutral. The morality comes from how we use them. The dark web isn't going away. As long as there is a need for anonymity, and as long as governments attempt surveillance, tools like Tor will exist. The question isn't whether it should exist. The question is, how do we balance privacy, security, and freedom in a digital world? And that's a question that doesn't have easy answers. If you found this video helpful and want to learn more about cybersecurity, cryptography, or network architecture, let me know in the comments what you'd like to see next.